There's Yusef. Hello, Yusef. You need to follow along what it says on the screen. Go to deltamath.com. You're going to create an account. You need that teacher code, and that is the section you want to add yourself to. And then you're going to try the problems that are going to show up. You're going to have 3 sets of 5 problems to do. Right? Okay. I'm going to take attendance when you guys are doing that. Here. Perfect attendance today. Timothy's in there, Alex is in there, Lane's in there, Sarah, Abby, Yusef's in, Donovan, Audrey, Rachel, Holmes, and Chloe, Savannah.
That's it.
Here, I'm kind of curious. How many of you were doing this like we're working on trig when we had all COVID stuff happen last year. And that's what we were doing online. Did anybody have it happen last year? Sine, cosine, tangent?
You did that before.
You did it before? You did it before? You did it before?
We did it before.
Okay. So it was not something you were doing online. That's what I want to see. I know it's been a while. And that's okay. This is just to check to see what have we retained. And I'll make sure you guys understand it. This is just a baseline, guys. This is just a baseline. If you don't remember most of this, I'm not going to be mad about it. It's okay. All right? It's okay. You guys get different problems?
Yeah.
That's what I thought. It should be different problems. I'm going to push on. Whose name should I go to?
No.
Oh, yeah. Oh, I'm watching you, Abby Durham.
Okay, that's
I'm watching yours right here in front of me.
Yes, sir.
You're doing the identifying trig ratio section right now.
You're right.
Right now, you haven't finished the first problem. It's okay, though. I'm not
I
mad
don't
about
remember
it.
any of this.
That's okay. It's okay. I'm not mad about it. Right now, I'm sensing there's okay, so I'm curious. Right now, how many of you feel like you really do not remember what's going on at all?
I sort of do, I sort of don't.
Sort of don't means you don't. Yeah. Don't worry about that. It didn't count right there. It was supposed to be for this.
Yeah, because I didn't know about it.
No, it was supposed to be for me to get an idea, and just don't worry about it. It's okay.
Yeah, I checked you back at 10 p.m.
Yeah, don't worry about it. It's okay.
Thank God. I did it then. I
It's
looked through my
okay.
old notes and remembered. So I remember everything, but only the
Oh, what is that? Oh, you go.
Hey, I see your first question, Abby.
Yes.
Looking at it right here in front of me.
Like I have an idea, but it's like I don't remember how to write it down.
I have a feeling we might want to just pause where we're at and do our lesson right now.
Wait, let me
Okay.
do one more.
I think we're gonna go ahead and I'm gonna ask you guys to we might just hold tight for a second and do a lesson today. Just go through.
How to keep time? Can you see like the questions that you did?
Yeah, I can. Once you've finished it, I can open it and see what you've done. Yes. Go back. And look at. I drew number. Oh, number 2. Let's look at number 2. Oh my God. Oh.
What is it called?
Oh God. Not the angle. No. That's why we're doing this. To make sure you guys understand what's going on, what those numbers really mean.
The only problem I'm having is it just gives me like the lines, and I'm just like, okay, so like it's hard to tell. Like bigger numbers, the biggest number.
Last time I checked it was. Okay. I think I want everyone to we're going to pause for a second here. We're going to come back. You're going to get a chance to work on this. Don't worry. It's not going anywhere. It's still there. Okay. So we're going to go through and do these are the things that you're going to be required to have an understanding of when we come back. Okay. So the first thing up here is I didn't even put on there. That's all trig. Okay. The first thing we're talking about real quick is just Pythagorean theorem. And I know everybody in here, guys, can do Pythagorean theorem. Now, there's 2 ways we use Pythagorean theorem. There's 2 ways we use it. Okay? One way is if you're given a right triangle, I can give you any two sides of a right triangle and you can find the missing side, right? A and B, those are the legs. C is the hypotenuse. This is something you guys know. That's one way we use it. The other way we use it is in classifying triangles. Okay? We classify triangles. So here's what we'll know. If a squared plus b squared equals c squared, then you're dealing with a right triangle. If a squared plus b squared is greater than c squared, you're dealing with an acute triangle. And if a squared plus b squared is less than c squared, it is an obtuse triangle. Did you guys do that or not? The classifying with them? Okay. So the two ways we use it are, one, given a right triangle, find missing side, one of the missing sides. The second way we use it is, given three lengths of a triangle, classifying it as a right triangle, an acute triangle, or an obtuse triangle. All these notes will be posted online. Okay? All of this will be posted online. Those are the two ways that we use the Pythagorean theorem. All righty? Okay. Now, we're not going to spend any more time on that. That's just right there. Okay? Here we go. Special right triangles. Okay, so this, we actually had a brief conversation, I think, about this. I'm not sure when it was in here. We had a conversation about special right triangles. 45, 45, 90s, or they're also called isosceles right triangles, and 30, 60, 90. Okay? So we're going to start with 45, 45, 90s. And what we're going to do is we're going to use knowledge, prior knowledge, Pythagorean theorem, and some other little theorems that we would know in order to find relationships that always exist on these special right triangles. So the first one we'll do is the 45, 45, 90. This one here. Okay? So 45, 45, 90, right here, 45, 45, 90, is also referred to as an isosceles right triangle. That's because if you have a triangle with two angles equal, the sides opposite of those angles have to be congruent as well. Okay? So I know it's also isosceles, this is guaranteed. Now, if they're congruent, that means they have the same length. I could just call both of these x. Okay? So we know their lengths are going to be the same. Let's go ahead and use Pythagorean theorem and find out what c is equal to. All right? So we're using Pythagorean theorem for this. So it'd be what? X squared plus x squared equals c squared, which means c squared is equal to 2x squared. Those are like terms. Just add them up. Take the square root of both sides. C, and I don't have negatives because there's no negative length here, right? C is equal to the square root of 2 times the square root of x squared. What is the square root of x squared? X. So it's x times radical 2. So on a 45, 45, 90, this is the relationship. The legs are both x, and the hypotenuse is x times radical 2. Every single time. That's the truth on a 45, 45, 90. Okay? It's just a relationship that exists. Which simply means if I give you one of the three sides, you can give the other two sides by using this knowledge. If I gave you, like all of a sudden, if I said, hey, I know that this right triangle here, this 45, 45, 90, this is 7. You automatically know this is 7 and that this is 7 times radical 2. Done. So if I give you that information, it's easy. I will tell you, you need to know this. You will need to know this. It's going to make your life easier when we come back from spring break. knowing this relationship, okay? All right. So here we go. Let's try it. Oh, I thought I had a couple problems on here. Let's try this. Let's just go ahead and do a couple. So, actually, I'll just put a new page in. Let's just get a new page. New page. All right. Do that one, find the missing sides. Oh, I forgot. I can't do that anymore. That's making me mad. I can't do the fist erase. Okay? Do these. Find the missing sides. Find the missing side. Using the special rectangle relationships. This should be done. Then you should be on to the second one over on the right. And you really should almost be done with the one on the right. War drums. All right, here we go. Palms up. Give me them. You do. Look at there. What is it? What's this to me? Look how they're marked. They're marked so they are what? What do these little marks mean? They're the same. If that's 8 radical 3, what's this? All right.
Oh, wait. No, I was confused. I didn't realize the 8 radical 3 was supposed to be like that length.
That's that length. Yeah. Okay, now, so those are both 8 radical 3. What am I going to do to find this? What did I do? What did I say to do back here? It's what? It's the length of the leg times radical 2. It'd be 8 radical 3 times radical 2, which is what? 8 radical 6. 3 times 2 is 6, right? That's it. That's it. Okay? Being able to do that. So on the right, I gave you the hypotenuse. So let's look up here real fast, guys. 45, 45, 90. X radical 2. Okay? If I give you either one of the legs and you want the hypotenuse, you multiply by radical 2. If I give you the hypotenuse and I want the legs, you're going to go the opposite direction. You're going to divide by radical 2. Divide by radical 2. 6 what? 6 radical 3 and 6 radical 3. Boom. Done. That's it. Okay? That's it. And remember for me, once we got done with, the quadratic chapter, I said you did not have to simplify radicals anymore unless they were what? Perfect squares. Like a square root of 4, I would expect you to put down 2, right? But you do not have to simplify them. You don't. Let's do one more. Here we go. Now you're going to get all mad, but you shouldn't. You should just make it easy on yourself. What am I going to do to get this? Divide by what? Divide by radical 2. So this is going to be 8 radical 9 divided by radical 2. Do you have to do anything with that? You could. What's the square root of 3? Or square root of 9? So you could make it what? I wrote this and I hoped you guys would tell me, well, Mr. Snyder, shouldn't that be? So I could make this 24 over radical 2. What's this going to be? Yeah. Okay. Do I have to rationalize this? No. Leave it alone. You don't have to do that. But we simplify perfect squares. Okay. Are we okay on the 45, 45, 90? What do you feel? Abby, are you okay with that? Did you see that last year or not? You did not see 45, 45, 90 special right triangles? Do you think you understand what it says? Here we go. Second one. All right. So the other one is a 30, 60, 90. The other special right triangle is a 30, 60, 90. And those names are based upon the angles in the triangle. 45, 45, 90, 30, 60, 90. Okay, so obviously these are not 30, 60, 90 right triangles. They're not. This is equilateral. Okay? Now what's that mean? If it's equilateral, what does that mean? All the sides are equal. Boom. So I can go ahead and mark those all the same. Great. Okay? If a triangle is equilateral, it is also equiangular, which means all the interior angles have to be what degree? 60 degrees. All right? So that's 60, that's 60, and that's 60. Okay, now we're going to come back to this picture in a second. Over here, guess what kind of triangle this is? It's isosceles. Thank you very much. These two are congruent. Those are called the legs of the isosceles triangle. Where the legs intersect, that angle is called the vertex angle. Okay? And this is called the base, and these are called the base angles. That's from geometry. If I draw an altitude from the vertex angle, in other words, if I were to draw this angle, or this altitude right here, boom, it has to do two things. Other than being perpendicular, because an altitude is always perpendicular. There are two things that it does. One, it bisects the vertex angle. It bisects it. In other words, this piece and this piece are going to be the same. The other thing it does is it bisects the base side. So these two pieces are going to be the same as well. Right? Because what happens is you end up getting two right triangles that are congruent to each other. Okay? And I know they're congruent by hypotenuse leg, or by what? Remember how to prove triangles congruent? Side, 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 angle, side, angle, side, angle, all those good things. We can show that those two triangles are congruent. Okay? Now, why did I even say that? An equilateral triangle is also isosceles. Because by definition, isosceles says has at least two sides congruent. Well, an equilateral has at least two sides congruent. It has three. That's at least two. So this is also isosceles. So I'm going to draw an altitude from this angle right here. And in doing so, that's going to bisect this angle up here, and this is going to be 30 and 30, and it's going to bisect this base down here like this. Okay? Are we all okay with that right now, what I've done? Now, why have I done that? Because that's how I get a 30, 60, 90 right triangle. 30, 60, 90. Okay? So I've just created a 30, 60, 90. Now, if this triangle was equilateral to start, that meant all three sides were equal. That would mean that this could have been x, and this could have been x, and this length would have been x. Who can tell me then what this is going to be right here? 1/2 x. Or x over 2 if you want to think of it that way. Okay? Guess what I now have? I now have the following. Let's go with purple. I have this right triangle here. Okay? And I know that this is x. This is x over 2. This was 60. That's 90. That's 30. I want to find this. How will I do that? Pythagorean theorem. All right. Now that's a leg. So I can call it either A or B. It doesn't matter. I'm just going to call it letter A. Okay? So here we go. a squared plus x over 2 squared equals x squared. A squared plus x squared over 4, square the top and bottom, equals x squared. A squared equals x squared minus x squared over 4. Now these are like terms. I want to combine them. I need a common denominator. All I have to do is make this 4 over 4. Because it's what's the coefficient of it? 1, so I can make it anything I want over itself. Why would I choose the denominator 4? Because that has a denominator of 4. So I'm just going to rename this 4x squared over 4. Oh, so what do I get? A squared equals 3x squared over 4. Are we okay with that so far? Is that part okay? I'm going to go over there and continue. A squared equals 3x squared over 4. Which means a squared equals x squared times 3 over 4. I just like writing that way. Okay, here we go. Take the square root of both sides. When I take the square root of a fraction, you take the square root of the top and the bottom. A equals, okay, what's the square root of x squared? X. Radical 3 over 2. Okay, now, it's not very nice. It's kind of gross looking, I have to say. Okay? Because this is x over 2, and this is x radical 3 over 2. I have a question for you. If I took this triangle and multiplied it by a scale of 2, a scale factor of 2, would it change, listen very carefully, would it change the relationship that these sides have to each other? No, because because the new triangle would be similar to the original one, so the relationship of corresponding sides would be the same. That's what similarity was all about. All right? So guess what I'm going to do? I'm going to multiply all of these by a scale factor of 2. Why? Because that's going to get rid of the denominator. So what I have now is this is where I'm at. I'm just going to multiply all of these by 2. Multiply this by 2, multiply this by 2, and multiply this by 2. So all I would do is create a new 30, 60, 90. That's just what? Twice as large on the sides. So what do I get? I get a triangle where the hypotenuse is what? 2x. This leg is x, and this one is x times radical 3. This is the relationship for a 30, 60, 90. Check that out. Okay? Check that out. That's beautiful. I'm going to rewrite it over here so you can see it again. So here it is. Boop, boop. I'll just change it around. Here's 30. Here's 60. Here's 90. This is x. This is 2x. This is x times radical 3. Okay? Now let's name these sides. We're going to name them. We know what this is called. This is the what? This is the hypotenuse. Okay. These are both legs. The leg opposite the 30, we call the short leg because it has to be shorter. And the leg across from the 60, we refer to it as the long leg. Once you know this relationship, I can give you one side of a 30, 60, 90, and you can give me the other two if you know this. It's all about multiplying or dividing by the right value. Okay? That's all it's about. So let's say I gave you a problem here. Can I get rid of this thing? Ah! Let's put it up there. Get out of the way. All right. So here we go. We're going to try one. thing is, which of the three sides did I give you? I gave you the long leg. Okay, now here's the deal. The path on this is you always want to try to find, if you're not given the short leg, you want to find it next. Okay? So if I'm here and I want to go to here, what am I going to do? What would I do? Divide by radical 3. Now, if you can't remember that, all you have to do is say, well, look, 5 radical 3 is equal to x radical 3, right? How do I solve this for x? Divide by radical 3. And that's really what you're doing. So x equals 5. That's the what? Short. Oh, then to go to the long leg, take the short leg and multiply it by 2, and you'd be done. Boop, there it is, done. I can tell you this works. Ready? Pythagorean theorem. 5 squared, 25. 5 radical 3 squared is 75. It's 25 times 3. 75 and 25 is 100. 10 squared is 100. Boom, works. Works every single time. It's a special right triangle, the 30, 60, 90 is. Okay? Now that one's a little harder. Try these 3. Try these 3, pleasey. Pleasey, pleasey. Don't sneezy. I gotta see how Maddie's. She's cheating. She's not. I'm lying. Okay. Yep. Making sure you're awake. I know the light's off. It's later in the day. Ow. Wow, ninja. That was pretty quick. All right. Let's start with the top left, this guy right here. Okay, so on this one, I've given you the short leg. So what do? I can go to either one of these I want. If I want the hypotenuse, just multiply it by 10. If I want the long leg, take the short leg times radical 3. 5 radical 3. There we go. Got it. This one, what did I start you with? Long leg. So I want to go to the short leg first. So what am I going to do? Divide by radical 3. So this is going to, so I'm literally going to divide by radical 3. So it's 5 radical 6 over radical 3. All I have to do is divide these. What's radical 6 divided by radical 3? So it's 5 radical 2. Now, from here to here, multiply by, so it's going to be 10 radical 2. Done. Okay, special right triangle, just knowing the relationship that exists. Last one, what did I give you? Gave you the hypotenuse. On this one here, okay, where am I headed first? Short leg, so it's going to be what? And then the long leg is? Boom. Okay. All right. So that's 45, 45, 90s, and 30, 60, 90s. And again, it comes back to knowing the two different relationships. Okay? And one last time, I'll just put them both on one board. 45, 45, 90. X radical 2. Ah! I need that thing. I need that ability to do that again. X radical 2, that's the 45, 45, 90, 30, 60, 90. X, 2x, x radical 3. So you're going to want to know this. Ah, look at that! Timing! Yes!
Yes.
Yeah, exactly. When you come back,
I'm so
we'll
bad.
keep moving forward.
I'm actually mad at that.
Stand up, tell me you too. Yeah. Yeah.
I need more sleep at night.
You do need more sleep at night. You know what you need to do?
I get like
Go to bed early, get up early.
3 hours of sleep.
Go to bed early, get up early. You'll feel better.
Sometimes I get like 10 hours and I feel even more tired.
I go to bed about 9:30. I get up at 4:30. Beautiful.
I'm so mad
I
at
don't know
that.
how much sleep
What?
I get.
I'm so mad at that, man.
Why?
This is giving me things that I'm not even getting.
Well, that's because you're not understanding what it's saying.
Well, the problem is
And we haven't even talked about what Delta Math's asking you to do yet. Because it didn't even ask you for this.
no, it doesn't.
Right. Once we go over the next part, the trig, you'll probably be fine in Delta Math.
Okay.
Okay?
I got the first one done. Perfectly
You'll be fine.
It's the third part that's like confusing me because it's like cosine bit of u is equal is
Yeah.
fraction, and then it's like I remember doing it and I
You
do
just
it,
gotta
and then-
wait.
and then it's like oh yeah, it's like 24, and then when I do it, it's like no, it's not. It's like 40 something.
You're, yeah, I know. Yeah, exactly. Ah. Woo! Man, oh man, oh man. What a great Dane. What?
Say Great Dane.
Maybe. Maybe I said great Danish.
Dude, Danishes
I
are
always-
so good.
I always say things like that to my advisor in the league. Have a great Dane! Have a great Danish!
Have a great day.
Yeah, that's what I'll say when they're leaving my class. They think I say it so fast, they think I'm just saying have a great day.
You have a freshman advisor?
Juniors,
Juniors.
gotta have fun. You gotta have fun!
I can't wait till senior day. Alright, let me know what happened.
Oh.
It's bright in here now.
But his parents like
have a game plan, but so like, you know, it's getting so close. It's not possible. Yeah, it is. Yeah. Why don't you just like download something? Because sometimes like it's not really reliable and this sucks. It doesn't work. Yeah, like layers of layers of layers. That on a phone you can sometimes it works, sometimes it doesn't.
I don't know. We'll have to see how long it takes.
The biggest thing I've ever done,
It's like
I've never been on a
Oh,
phone.
well,
No, right here.
the one
right
thing
here,
to
I've never been on a
tomorrow.
phone. I've only ever been. Yeah. Like those are just the really big, really big things. The biggest thing I've ever been on,
I start bringing
the biggest thing I've ever been on,
one day I did it right.
only had one arm in the middle, but the bathroom was in the middle. I do not get it out of my house. Ever. I like that. And sometimes I just have to feel like I wish I was in the airport. There's just something about vegan. It's just so fun. And like all this stuff, and like I blend in one thing, like already there. Yeah, it's and I'm a total freak. Like anything with socks off, that's when a girl takes their shoes off. Nonsense. That's kind of taking your shoes off is fun. As long as you're not like a freak and you're sweat. And then like I just said, I had to ask him that I was trying to get the snacks first too. And I just don't want to feel like it's constricted. But I would be with shoes between the two she's out. I had to do the middle. Because there was one time where me and my mom and my dad and sister were not all in the same row because it was freeze. And so I had a different spot. And so me and Katie were in this spot. And so he was in the ass, and he was in the ass, and he was like, and so I was like, literally as far as those as I possibly go. Because I'm like, this is small, dude. It really isn't a big sport. I mean, big. I mean, like, those nuts were huge.
Abby, are you ready?
No.
Are you ready, Abby?
Oh, yeah, I didn't even.
Are you ready?
I just closed and I said.
All right, let's keep going here. So, get one of these lights. That's it. Hey, that's better. All right. So, boom, rules for special right triangles. So we talked about Pythagorean theorem. We've talked about special right triangles. The other big thing to talk about in here is right triangle trig / trig ratios, right? Okay, so this is like not necessarily in right triangles, but trig is going to be a huge part of the remainder of the year. So it's very important that we understand what's going on here. So for right triangle trig ratios, there were 3 of them for you guys. 3, okay? And they were sine, cosine, and tangent. And okay, sine, cosine, and tangent. And then sine, of course, was abbreviated SIN, cosine was COS, and tangent is abbreviated tan. Okay, boom. So those things should look familiar to you. All right. Here we go. Then you learn this. I guarantee you, every one of you had your teacher say that to you in class. So if it's O, okay, so the first letter, of course, in each one of those, S is sine, C is cosine, T is tangent. The O's, the H's, and the A's stand for something dealing with the right triangle. So what do we know about those? Well, let's say we're over here. And let's say I'm going to focus on angle C. If angle C is the angle I'm interested in this problem, I'm using it, I'm finding it, whatever it is, then the sides are labeled relative to their position to that angle. Now we automatically know that this is the hypotenuse, so that's a given. It's the legs, okay? So if I'm concentrating on angle C, the leg across from it is referred to as the opposite leg. And the leg next to it that helps make the angle is referred to as the adjacent leg. So that's where the O and the A and the H come from. Those are opposite, adjacent, and hypotenuse. So this is telling us that the sine ratio, the sine of an angle, is formed by taking the opposite leg divided by the hypotenuse. The cosine of an angle is the adjacent leg divided by the hypotenuse. And the tangent of an angle is the opposite leg divided by the adjacent leg. So let's write this down. This would be saying for this right triangle, if I'm using angle C, that the sine of angle C is equal to AB over AC. That's what it's defined as, okay? The cosine of angle C would be adjacent over hypotenuse. So it would be BC over AC. And the tangent of the angle C would be opposite AD over adjacent BC. So what you get are you get these little equations, okay? And each equation has three things. It's got either sine, cosine, tangent of an angle, and then it has two lengths of the right triangle. All right? Okay, so when you get these numbers back, like if I were to write down the following, okay, if I said to you, hey, the sine of angle C is 0.866. What if I told you that? Okay? If I told you that the sine of C is 0.866, what in the world does that mean? What does that even mean? Because on your calculator, if you type in some angle C, sine of some angle C, you'll get back 0.866. What does that 0.866 mean? Does anybody know? Here's my right triangle, here's angle C. I don't know what angle C is, it's just right there. What does this sine of C equals 0.866 really mean? Well, this means that the side what? Opposite angle C, let's call it X, divided by the hypotenuse equals this. Oops. Ah, I'm so mad. Okay. There it is. If I take opposite leg divided by hypotenuse, I'm going to get back 0.866. And that's true if my triangle looks like this, or if I do this to it. That's still true. It doesn't matter. No matter what, this is saying, hey, all of these triangles right here, the sine of C is equal to X over C is 0.866. It always stays 0.866. Why? Because all of these triangles are similar. Okay, they're all similar. So that x over c ratio does not change when I go like this. Okay, it doesn't change if I do any of those things. It stays the same. Okay, great. So that's all that means. All right? Now, how do we actually use these trig values? How do we use this? There's two ways we use trig. Okay? Oh, I don't want that. Here we go. One of them is to find missing sides if you're given an angle and a side. One thing we can do is find missing side lengths of a right triangle if we're given an angle and one side. So let's go ahead and look at this problem right here. And let's say I wanted to solve for C and A to the nearest 100. The first thing I want to do is I want to identify where are my sides relative to the angle I'm going to be using in this problem. There's my angle. So I'm going to label these. This, of course, is the hypotenuse. This is the adjacent. And this is the opposite. Okay? So let's say I want to start by finding angle or side A. I want to start with this. This is the first one I'm going to do. All right. I'm going to use these three things right here. So I'm using this angle, I'm using the opposite and the adjacent. Oh, opposite, adjacent. Which ratio is defined as opposite over adjacent? Tangent. So I would write down the tangent of 18 degrees is equal to 3 over A. You guys remember doing that? Abby, does that look familiar? Kind of? Yeah? Okay. We're not going to solve it yet. This is just the setup. This is the equation. We have to solve this. If I wanted to do letter C over here, let's do that one. Now I'm using this angle, this side, and I'm using the hypotenuse. So which ratio is opposite and hypotenuse? Sine. So I would write down that the sine of 18 degrees is 3 over C. Okay. Now, how do I solve these? How do I solve this? Put this over 1. It's a proportion. Two equal ratios are called a proportion. Okay? All I'd have to do, if I want to solve this, is take 3 times 1, divide by tangent 18, and that gives me A. Okay? Literally, that's all I'm going to do. So A is 3 times 1, 3, divided by the tangent of 18 degrees. Over here, same thing. Put it over 1. What's C equal to? C is 3 divided by the sine of 18 degrees. Now I have to use a calculator. The calculator now is going to help me find my answers to this. So we're going to use Desmos. You don't have to. You can use a regular calculator, graphing calculator, Desmos, graphing calculator, a Desmos regular calculator. The choice is yours. Okay? Let's see here. Wrong one. All right, here we go. So let me bring this over. So we're going to solve this 3 over tangent of 18 to start. Okay, now I have two this is a, for a Desmos, this is just a plain old, oh, that's the wrong one. I want this one. This is just a plain old scientific calculator right here, which you can use for this. Okay? Notice right down here it says sine, cosine, and tangent. Beautiful. So I could literally just do 3 divided by the tangent of 18 degrees, and I will get my answer. Done. Okay? Boom. That was pretty easy. Now, what about if I was doing it on a graphing one like this? What would I do? Well, guess what I would do? I have a couple choices. My best choice is I'm just going to go 3 divided by, and I'm going to just type T-A-N, and Desmos says, oh, you want the tangent. They know it's not a color. And I'm just going to type in 18. And then I get this, and you go, whoa, that's not the same answer, Mr. Snyder. Well, there's a reason it's not the same answer. It is because this is in the wrong setting. Now, this is important whether you're using a calculator, Desmos, it doesn't matter. Your calculator or Desmos needs to make sure it's in degree mode. Right now, this is in radians mode. If I click degree and change it to degree where that 18 is 18 degrees, boop, I'll get the same answer. So you need to make sure that you're in degree mode when you're doing these problems. Okay? If you're using a small calculator, most likely on the screen somewhere it says either DRG or RAD, something like that. That tells you what mode it is in. Okay? If you're on a graphing calculator, you literally would have to go into mode and check to see what setting it's in. And I can help you with that. So there we go. Boom. Let's do the second one. So we know the first one is going to be 9.23. So the answer to this one right here is 9.23. I'm just going to type it. 9.23. Got it. All right. Now let's do the second one here. C equals 3 divided by the sine of 18. We can do that because we have technology at our hands. I'm just going to do it right here. I love this. 3 divided by the sine of 18. 9.71. 9 point. Okay, what's wrong?
Hang on just a second. We saw braille mode.
Oh yeah, you don't want that probably.
But why is there even a braille mode?
That's a good question. I'm not quite sure. So boom, we found them. So A is 9.23 and C is 9.71. Does that look at all familiar to you guys? Finding missing sides given an angle and a side. If that looks familiar to you and you think with some practice you might be able to do it again, raise your hand. Oh boy. All right. Well, let's just try another one. Let's try one more of those. Here we go. Let's see here. I'm going to give you this is, oh, here we go. That is 32 degrees. This is 24. I want you to find A and B. So the first thing I want you to do is I want you to write down two different equations. One to find A and one to find B. So you've got like 30 seconds to do that. Bump, 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 boom. All right. First thing I'm going to do, I need to make sure I know what I got. Here's my angle. I was given the hypotenuse. This is adjacent. This is opposite. All right, let's start with letter A. If I'm finding letter A, I'm using adjacent, this angle, and hypotenuse. I got to use the stuff I know. So which ratio uses adjacent and hypotenuse? Cosine does. Okay, so I would write the cosine of 32 degrees is equal to A over 24. There's the setup. There's the equation. If I'm doing letter B, all right, if I'm going to do letter B, it's going to be, hey, I'm using this angle opposite and hypotenuse. Now I have to use the sine ratio. So the sine of 32 degrees is equal to B over 24. All right. So how am I going to solve for A on this one? A is simply going to be what? 24 times the cosine of 32 degrees. And you're probably thinking, well, why didn't I divide? Because this time my unknown's on the top. Before, where was it at? On the bottom. Because we're variables. You don't always multiply, you don't always divide. You have to think about what you're going to do. So, you multiply those by 24. Boop, boop, boop. What's B going to equal? B is going to equal 24 times the sine of 32 degrees. And then it's all about using your calculatrice. So let's use the calculatrice. Figure these out. Masks. Bump, bump. All righty. So we'll get rid of these. So I'm simply going to type in 24. The first one I did was what? Cosine of 32. Boom. There it is. 20.35. The second one was 24 times the sine of 32. Quack, quack. So I've got 12.72 and 20.35. 12.72, 20.35. Right? Boom. That is what you're doing here. Trying to use trig to find missing sides. Okay. This is what Delta Math's going to be asking you to do today. So it's going to ask you to identify which ratio you're using. It's going to ask you to find missing sides or one side given an angle and a side. Now, the other thing that can happen is you're not always given an angle. Okay? Here I gave you one angle, one side, asked you to find the missing sides. It is possible that you will be given not that, but two sides and asked to find a missing angle. So here I have a right triangle up here, and you'll notice at the bottom right, I've got an arc drawn on that angle. I've got an arc on it. Okay? Notice I didn't name the triangle. I just didn't name it. I didn't feel like it. I want you to understand, in this class, when we are working with angles or rotations, we will use Greek letters for variables. They're letters. Variables are letters that represent or stand for numbers. That's all they do. When we're talking about rotations and angles, we switch from Arabic letters like our A, B, C, D, blah, 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 blah. We switch to Greek letters. Okay? The most common letters we use are theta, phi, okay? Alpha. I'll do that myself. Alpha looks like this, and this is beta. It's like a B with a tail, right? Those are the most common ones that I will probably use. If I use any other ones, I will tell you what they are. Chances are things like gamma I might use, okay? But I don't use that one a lot. I try to stick to these four. So I'm going to call this angle up here angle theta. I want to find theta. All right. So again, I have to identify where are the sides relative to the angle I'm interested in. Here's my angle I want to find. Where is this side relative to this? It is opposite. This, of course, is the hypotenuse. So the ratio I could write down, opposite over hypotenuse, is the what ratio? Sine. I could write that the sine of theta is equal to 9/15. All right. Now, how in the world do I solve this for theta? Well, I don't want to use sine. I want to use inverse sine. So you literally, there's two ways this can be written. Theta is either this, inverse sine, that inverse functions do what? Go opposite directions, okay? Inverse sine of 9/15. That's one way to get it. Or you can write it like this. Arc sine. Now, you might be thinking, arc sine, that's a weird thing to call it. Well, not really. You know why? This is an arc, isn't it? If you remember anything from geometry, the measure of a central angle and the intercepted arc are equal in degrees. So if you're finding the measure of this angle, you are also finding the measure of this arc. Okay? So you can write it either way you want. This is how you find the angle if you're given sides. So we go to Desmos again. All right, so on Desmos, let's go back to this scientific one to start because I want to talk about it. So here, you'll notice there is no inverse sine, inverse cosine. It's not there. You would have to go to function, and then you have to go ahead and type. You have to click this one here. So I want to use inverse sine, and then I want to do what? I have to go back to main, and then I want to do, what was it? 9 divided by 15. Boom. There's my angle, okay? There's one option. If you're pretty cool, you could just type in arc sine and then put in parentheses 9 divided by 15, and it will understand that as well. And that's actually quicker than going over, clicking function, going back to the main. So you can type either one of those, and it will work. Now let's go to the graphing one, okay? Right here. I'm just going to type in sine raised to the -1, and the calculator says, oh, you want to find the inverse sine of, and then I'm going to put 9 divided by 15. Boop, got it. Or I can type right here, arc sine of 9 divided by 15, and I'll get the same answer. So Desmos recognizes things when you type them in, okay? So the answer to this is 36.87 degrees. Theta equals 36.87 degrees. 36.87, let's see, degrees. That's theta. Those are the two different ways you use trig in geometry. Given angle and a side, find the missing sides. Given two sides, find missing angles. All right? Okay. So that's what you're going to be practicing. That's what you're going to be practicing. So let's see. Do I have another practice problem for you? I don't think I do. Let's put another practice problem on here. Hello?
Hi. That's fine. Thank you.
Oh, you bet. No problem. All right. So I'm just going to give you one to practice like this. Here we go. So I'm going to build a ramp. Okay? I'm going to build a ramp, and I know the following. I know I need this distance here to be, I don't know, 20. And I know I want this to be 2.5. I want to know what this angle theta is right there. What is the angle of incline? If that was a ramp. Let's see if you can solve that one. Okay? While I bring in Maddie's detention desk. Gotcha. What ratio are you using? Are you using sine, cosine, or tangent?
I'm figuring out.
Figuring it out, okay. Abby, that's my angle. Where is this compared to it?
Opposite.
Okay. Where's this?
Adjacent.
Which one uses opposite and adjacent?
Tangent.
You figured it out. Here we go. Let's round this to the nearest hundredth. Hamza, you got it?
No, but
Oh,
I
okay.
did have that, but I didn't actually put it in the calculator.
Oh, put it in the calculatrice. I need an answer. What do you guys think? Should be pretty small. What'd you get?
0.125.
That's what this is? This is not, it should be, did you do, yeah. Oh, yeah, that's what this is, but you need to do second tangent
Oh.
of that 0.0, whatever you just said it was, okay?
7.125.
You get the right answer now, Abby? Did you get 7.125? So 7 point,
pass their packet?
no, I'm just gonna email it to them.
Okay,
Yeah, tomorrow I'm gonna finish it up. I have to add about another 3 pages of problems.
probably after today, you just wanted to make sure.
Yeah, because some of them didn't remember this from geometry last year, so I'll have to add this on there now. It's unbelievable.
Okay.
You got it? Okay, great. So there you go. That's what you're doing, guys. That's what the Delta Math assignment's about. It's about identifying sine, cosine, tangent, finding missing sides using sine, cosine, tangent, and finding missing angles using sine, cosine, and tangent. That is there for you to practice on. So I know how we're doing on this. And when we come back, I feel like we're poopy at this, then we'll have to fix that. Okay? I'm hoping that you will not be poopy at it. I'd appreciate not having poop in my classroom. That's boo. I don't want no poopy poo in here. Okay? We good? So now you're back to Delta Math. Did you sign up for the Delta Math already?
Yeah, I made it now.
Okay. Yusef, get to work. Yusef, I'm going to be sending home a huge packet of problems for you to do.
Okay.
I want you to know that. All right, so I'm going to stop sharing.